the n-queen problem. Okay, the problem is that we have to place n queens on an n by n chessboard so that no two queen attacks, that is no two of them are on the same row, column or diagonal. Okay, so here is the algorithm to solve n queen problem. I will explain it with an example of 4 queen problem. That is, we have to place 4 queen in a 4 by 4 chessboard. Okay, and imagine that I have already placed the first queen in second column and second queen in fourth column. Okay, so next I am going to place the third queen in the third row. Okay, so I have 4 choices I can place in first column, second column, third column or fourth column. Okay, so this algorithm will help me to find the exact position where I can place the third queen. Okay, so now I will call n queen of 3, 4. I am going to place third queen and I have 4 choices. Okay, that n is 4 here. Okay, so this for loop, the first for loop is repeat from I equal to 1 to n. That is, we have to check whether I can place in first, second, third or fourth. Okay, for that we are using this for loop. Okay, and then we will call the place procedure or the place algorithm. The place algorithm will check whether I can place this queen in the first column, second column or third column or whatever it is. Okay, so the place algorithm will take input as the queen we have to place. That is, we are placing the third queen, and initially I will be 1. That is, I will give the value 3 1 as input to the place algorithm. Okay, that is place algorithm. Now we'll check whether you can place the third queen in first column or not. Okay, like that we will repeat. If it is not possible, we will check whether I can place the third queen in second row by increment the value of this I until the value of I becomes 4. Okay, so in the place algorithm it will repeat j equal to 1 to k minus 1. That is, I have to check whether in my upper rows, that is in the row 1 and row 2, whether the queens are in attacking position or not. Okay, that is why it is repeating only up to k minus 1. I don't need to check the below rows. Okay, the row below me, because there will not be any queens in that row. Okay, so this if condition is actually checking whether I can place it or not. Okay, it has two parts. The first part will check I can place it in a particular column or not, and the second part will check whether is there any queues in the diagonals, so that that will attack my current queue. Okay, so the first part I will explain first, and the next part I will explain soon. Okay, so in the first part, suppose j is equal to 1, I am checking x of 1 is equal to I is 1. That is, whether I am checking x of 1. If the first queen is placed in the first column, then x of 1 will be 1. Okay, so if x of 1 is 1, means that the first queen is in the first column, so you cannot place it. Okay, that is, if this condition is true, I am returning false. Okay, like that when j become 2, I will check whether x of 2 is 1. That is, whether the second queen is in first column or not. Currently the first queen is in second column and the second queen is in fourth column. Okay, so these two for j equal to 1 and 2, this condition will fail. This condition will fail, so it will return true. Okay, but if first queen is in the first column, it will return false, or if the second queen is in the first column, then also it will return false. Okay, that is, this part is checking whether the column is already occupied or not. Okay, now this part is going to check whether the diagonals are already occupied or not. Okay, that is, when j is equal to 1, we are checking whether x of j, that is x of 1 minus I, here I is 1. Okay, that is, the value of x of 1 is here, now it is 2. Okay, 2 minus 1 is equal to 1. Okay, we are taking absolute values, but that is, sometimes we will get negative value, so we will ignore the sign. That is why I am using the function absolute to take the absolute value. Okay, so then I will take the absolute value of j minus k. Here j is equal to 1 and k is 3, so 1 minus 3 is 2, so absolute value is 2. Okay, so these two are not equal. Okay, suppose imagine that the queen 2 was here, queen 2 is here in the second column. Okay, then when j becomes 2, I will take a absolute value of x of 2. X of 2 is suppose now it is 4. If it is here, this value becomes 1. Okay, so x of 2 is 1. Okay, sorry, if I the second queen is in the second column, then x of 2 will be equal to 2. Okay, so now imagine like the second queen is in the second column, so x of 2 is 2. Okay, and 2 minus value of I is 1, so 2 minus 1 is equal to 1, and absolute value of j minus k, j is 2 and k is 3, so 2 minus 3 is equal to 1, both are equal to 1. Okay, that is how I am finding the diagonal. Okay, so I have to check only the immediate diagonal. This diagonal I will not check. So this queen is in the line of attack. Okay, so I cannot place the third queen in the first column if there is a queen in the second column. Okay, so this part is will check whether there is a queen in diagonal or not. If there is a queen in the diagonal, then it will return false, otherwise it will return true. Now in our condition, the queen is in the fourth column, so it will return true, and we can place it in first column. We can place the third queen in first column. So x of 3 I will set as 1. Okay, then if k becomes n, that is if fourth queen also placed, then I will write the solution. Otherwise I will repeat the procedure with the next queen, that is the fourth queen.